Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 13, Roman to integer. This is a medium difficulty problem, and it's a great one for practicing your algorithm design skills. The challenge is simple. Given a Roman numeral string, convert it to its integer equivalent. For example, III would be 3, LVII would be 58, and MCMXCV would be 1994. Seems straightforward, right? But there's a bit of a twist. Roman numerals use subtractive notation. For instance, IV is 4, not 6, because the I is subtracted from the V. Similarly, IX is 9, XL is 40, XC is 90, CD is 400, and CM is 900. We'll explore how to handle these subtractive cases efficiently. So, buckle up, let's dive into this fascinating problem and master its solution together. Understanding with examples. Let's solidify our understanding with some examples. Consider III. This is straightforward. 3 i's, each representing 1, giving us a total of 3. Now let's look at IX. Here we have an I before an X. Since I, 1, is less than X, 10, we subtract I from X, resulting in 9. Let's tackle LVII. We have L, 50, V, 5, and 3 i's, 3. Adding them together, we get 58. Finally, consider a more complex example like MCMXCV. We can break it down. M, 1000, CM, 900, XC, 90, and IV, 4, which sums up to 1994. Seeing these examples helps visualize the pattern and understand how subtractive notation works. Now we'll explore different approaches to solving this problem. Brute force approach. One naive approach would be a brute force method. We could iterate through the Roman numeral string, mapping each character to its integer value. We then add these values together, considering subtractive cases using conditional statements. For example, if we encounter IV, we'd specifically handle it as 4, instead of adding 1 and 5 separately. However, this method has its limitations. It's not very elegant and might become cumbersome with complex Roman numerals. The time complexity of this approach would be O of n, where n is the length of the Roman numeral string. While it's not terrible, we can strive for a more efficient solution. We'll soon see how a slightly more sophisticated approach can greatly improve our efficiency. Optimal solution. A more efficient approach involves iterating through the Roman numeral string from right to left. We maintain a variable to store the current total. As we move from right to left, we compare the value of the current character with the value of the next character. If the current character's value is less than the next character's value, we subtract it from the total. Otherwise, we add it. This elegantly handles the subtractive notation. For instance, when we encounter IV, since I, 1, less than V, 5, we'd subtract 1 from the total instead of adding it. This approach cleverly avoids extra conditional checks and simplifies the logic significantly. This approach is far more efficient than the brute force approach, providing a cleaner and faster solution, reducing the need for lengthy if-else statements. Code implementation. Let's see the code in Python. We'll create a dictionary to map Roman numerals to their integer values. Then we'll iterate through the string from right to left, applying the logic we just discussed. We initialize the total to 0. For each character, we check if its value is less than the next character's value. If it is, we subtract it, otherwise we add it. Finally, we return the total. This concise code efficiently converts Roman numerals to integers. Let's step through the code line by line, highlighting key elements and explaining the flow of execution. Time and space complexity. The time complexity of this optimal solution is O of n, where n is the length of the Roman numeral string, because we iterate through the string once. The space complexity is O of 1, as we only use a constant amount of extra space for the dictionary and a few variables. This is a significant improvement over the brute force approach in terms of both time and space efficiency. We optimized our algorithm to have a linear time complexity and constant space complexity, making it highly efficient for even large Roman numeral strings. This optimized solution is ideal for coding interviews where efficiency is crucial. Engagement break. So, what did you think of that solution? Did you approach the problem differently? Let me know in the comments below. And don't forget to like this video if it helped you understand the Roman to integer problem. Also, subscribe to the channel for more LeetCode tutorials and algorithm walkthroughs. Hit that notification bell so you don't miss out on future videos. Share this video with your friends who are also preparing for coding interviews. Let's help each other learn and grow. Conclusion. In this video, we successfully solved the LeetCode Roman to integer problem. We explored a brute force approach and then implemented a more efficient optimal solution with linear time and constant space complexity. Remember, understanding the problem and choosing